Hi everyone. Yeah, as I said, I'm Patrick. I'm a chairperson in Python Italia. We organize the annual conference in Florence. And I'm full stack developer at Sting Studios, which is a web agency. We do mainly website for clients, but we also have internal products. And yeah, you can find me online as Patrick91 almost everywhere. So yeah, today I'm going to talk about Django and especially GraphQL. But first, let me do a quick recap on the modern web. As probably everyone knows, the web started as a collection of documents, so there were like small web pages with just few information on it, and nothing was like dynamic. But then it slowly grew up to be something that is basically everywhere. So we have applications, web application on our phones, even on our smartwatch and stuff. So we started from single websites, so just pages, to complex interactive application. And one of the best practice was to use REST, which is basically kind of specification to do interaction with client and servers. So you can ask for data and get the data back. But there are some issues. But yeah, don't get me wrong, I like REST. It's a nice specification, but since we have moved to more complex application and also a wide number of devices that we are using, probably REST is not always the best solution. So for example, one of the main issues is that you have too many API calls. So for example, you want to get the user, you do a GET request to this endpoint, and then you get this data. And in this example, you get a user with a name, a list of friends, and an avatar. And imagine that you are displaying, like, for example, the user profile, and you want to show up the friends. You need to do a query for each of the other friends, which is potentially a waste. One solution to this is to make an endpoint, which is like this. So get user with friends, and you get something like this. But then you need to have other use cases. For example, on a mobile application, you need to display the avatar of the user or something else. So you do another endpoint and so on. And it grows up quite fast. And for example, I was reading the other day, there's Coursera. I think they have 1,400 endpoints, which is a lot to maintain, especially if you are new developers. Then they have to understand how your system works. And another solution could be that you have only one endpoint, for example, for the user, and you return everything, but then you have too much data. And it's another waste. It's a waste of bandwidth. It's a waste of resources. For example, if you have users in poor countries that don't have a fast bandwidth, or they have low-res phone and stuff, you are sending too much data that's not used, and yeah, you're wasting your user money and time as well. In other words, you can say the REST is like a plate, and you are in a canteen, so you want to get some food. You go to the canteen and you say, oh, I want this. But since you have only a plate, you have to do more than one round trip. And you can see GraphQL as a tray. So you have more than one, more than one box where you can put your food. So you go to the canteen and you ask for all your food that you want, and you get everything back. And GraphQL was created by Facebook. It's not like a language. It's a language, but it's not like an implementation. It's only a specification. It was created in around 2012, and it was made open source around 2015. I think this year has been released under the Open Web API, so it's free to use without any patents issue that you might have heard of. So yeah, GraphQL is designed to build client application by providing an intuitive and flexible syntax for describing their data requirements and interaction. This is how GraphQL is described in the specification. I think it's quite abstract, so let me show you an example. This is GraphQL. This is how you do a query. So this is how you ask data, for example, in the API that we have seen before. So you have a user, you can get the name, the email, friends, and you can get the friend's name. And when you call this query, you can get this data back, which is exactly what you asked for. And instead of having more than one endpoint, you only have a single endpoint, which is going to be usually /GraphQL, and you do only post requests. So you cannot do GET. Everything is a post request. And something that's really helpful, especially for new developers, or especially if you have to, for example, if you're working as a backend developer, you have to send the API to the front-end developers. Sometimes it's hard because you have to provide documentation on this stuff. Well, with GraphQL, you have types, so everything is typed. You get a schema back, which has got all the types in your GraphQL schema. So, for example, for the user, you can have this type, which is a type user with a name, which is a string, and this mandatory. Email, same thing, and friends, which is a list of friends, and it's mandatory. Then you have introspection, which I'm going to show a demo of this soon. But basically, every GraphQL schema, if you want to, it returns all the debug information, so you know all the types, all the documentation, and everything. So, for example, you can build something like this. This is graphical, which is an IDE for GraphQL. As you can see, as we type, you can get the documentation, you can get autocompletion and stuff. You also get errors. So for example, something that we did at work right now is we have a project for a client, which is a basic website by using GraphQL. Basically, every time we commit the site to GitHub, we have a CircleCI hook that runs all the checks on the GraphQL schema. So basically, we don't deploy anything that can be broken. So we check the types. If there is a query that's wrong, it's not going to be deployed. So as I said, you have queries. Queries is the way in which you get data with GraphQL. So let me show you the anatomy of a query. So this is a query. I think so basically, you describe. Oh, no, sorry, that's not. I think I lost. Yeah. This is a query. Basically, you select the field. You can pass some arguments. So if you want to change some information output, you then have the subfields. For in this case, you have human, name, and height. And for example, you are getting the user with the ID 1000, the name, and the height with the unit foot. But this is the shorthand for a GraphQL query. The actual query is this one. So you have an operation type, an operation name, variable definition, and then you have the fields. So the operation type is something that basically specifies what you're doing. So in this case, you're doing a query. But I'm going to show later, you can also do other kinds of stuff. For example, you can do mutation, so if you want to change the data. Then you have an operation name, which is only a nice name, because since you don't have endpoints anymore, you need some sort of way to debug this stuff in the backend. So operation name is what is going to be shown on your logs, for example. And then you have variable definitions, because, for example, you have the query in one part, and then the variables are just fed in from your client. And then you have the fields. So in this case, you get something like this. Actually, let me show you a quick demo on this. So this is the okay. So this is the IDE that I showed you before. I did this demo yesterday, so I don't really remember everything. But as you can see, there is autocomplete, so I can see what's in there. So I have a field called users, and as you can see, it's showing an error already. So I can see that this is a type with some that has subfields. So I can get, for example, in this case, the first name. I can query, and I get the data back. I can also get the last name, and so on. And also, as I said before, every GraphQL schema has got a schema in it, so the definition, so you can get the schema for this endpoint, and you can see all the types. So in this case, you can see I have query, which is the main query, so with all the fields. Then there is person, type, string, which are the basic types, and so on, which is quite helpful, especially if you need to give this to front end and so on. Okay. So then you have mutation. Mutation is the GraphQL way to do changes on the server. For example, if you need to register a user, if you need to change some data, delete some stuff, use mutation for this. And they are similar to the queries. I can show you this one as well. Oops. Okay, so I did. I couldn't come up with. Couldn't come up with a good example, so I did mutation for the sum. So you can do sum A, which is one number, B, which is another number. Then you can get the results, which is in this case the sum. So you run this, you get the sum back. It's a stupid API, but it shows you the power of GraphQL. In this case, I use the shorthand as well for the mutation, but you usually would like to specify the variables as actual variables, not coding them. Then you can pass them as an additional JSON. Let me go back to this slide. Then there is another thing, which is subscription. Basically, it's a GraphQL way to do live updates on the front end. So for example, you want to get the feed of the user. You can do a standard query. But instead of using query, you say subscription, and then the server is going to send data back. Obviously, this needs to be implemented on the server as well. And yeah, that said, how we use this stuff in Python. There is only one library, as far as I know, which is called Graphene. You can install it like this, and then you can use it like this. Basically, you import the library, you create, in this case, I'm creating a query with only one field. And every field usually has a resolve function method. In this case, I have hello, which is a field of type string, and then you have a function called resolve hello, which is going to return the string word. It's quite simple. And then there is you create the schema. Schema equals graphene.schema, pass in the query, and then you can execute the schema. Obviously, you won't do this in line, but you would do this with your front-end code or even with another client. And then you can do the same similar for Django. You install Graphene Django, you add it to the settings.py, so it's at the install apps, you say which is the main schema. In this case, it's the schema variable inside the API/schema file. Then you add the GraphQL URL. And yeah, you can see there is graphical true, so you have the debug interface that if you want. And then you can use the types that have been provided by Django GraphQL. So you don't have to write all your types. You can just use the models that you have. And so you can use your standard Django models directly. For example, in this case, I'm creating an ingredient type that extends the Django object type. And then I'm using the model ingredient. And then I'm creating the query, which is, as we saw before, there's a field called all ingredients, which is a list. And then you have a resolve function, which is going to return for now all the ingredients. And then you create the schema. Something that I've done a few months ago is the REST framework integration. Because we had a project at work which was using a Django REST framework, and we need a way to use, we wanted to use GraphQL, so instead of rewriting all the serializer that we have done, we decided to make a integration for Graphene Django. So I made this one, and it works similar to the model one, but it works for the mutation, so you can use the serializer and do mutation and stuff. The only problem right now is that this has been integrated in Graphene 2.0, which is still in dev. So it's not, you can use it, but there might be some bugs with the other stuff. So this is like the gist of why you can use GraphQL. Something that I'm following quite a lot the development of the library. Something that comes up quite often is the security. Since this is not using like standard HTTP stuff, the security is something different. For example, the authentication, there is nothing in the GraphQL specification that says how you should authenticate, so you can use anything that you want. Something that I personally use is the JWT tokens, and I send an header every time I do a request. But this is just a way to do authentication. You can use, for example, session authentication if you have like a standard application that it's only using GraphQL for some bits of the page. But if you have a single page application, you have to use something like basic host, JWT token, or even you can specify the token in the query directly if you want to. But it's something that I don't really like. Then there is another stuff, which is permission. Right now, you don't really have any more like models or endpoints and all this stuff. You have like queries and fields. So something that's different is the permission model, which is not anymore a endpoint-based permission, but I think it can be said that it's a field-based permission. For example, GitHub is doing something that is quite interesting. If you are logged as an unbid for a project, you can see all the fields. If your user are logged, for example, as just like a normal user, you can see only some fields. I mean, you can still see them in the documentation, but you cannot access them. You get an error. And something that they're still also doing is they have private fields. For example, they're using GraphQL also for the internal API, which is shared between the internal and public. And they mark some field as private, so you cannot see even if it's in the GraphQL API. It's not even showing in the documentation, which is quite interesting. And as we said, since you give control to the user, to the client, you can do long queries, you can do DOS attacks quite easily because you can say, oh, I need the user from 0 to 1,000, 1 million, and so on, so you can have long queries. And one approach that's done by GitHub is using cost of a query. So for example, you have this query which is getting the first 50 repository, and for each repo it's going to get the first 10 issues. And they have this algorithm that's basically calculating the cost of the query. So there is 50 repository, 10 issues per repository. So you get 50 plus 500, and you get 550 total nodes. So you can, for example, you can limit the query to, I don't know, 1,000, for example. If the user is going to ask more than that, you can just throw an error, for example. So you prevent this kind of issue. Another thing that's done, I think, yeah, it's done by Facebook, is using static queries. Basically, with their new client, instead of building the queries on the client, during like the building step, they get all the queries, they analyze them, and they create like some identifier for each query. So on the backend, you have some sort of mapping between the identifier to the query. And so on the client, you only specify, oh, I need to do this query with ID 1, 2, 3, for example. And this is something that's helpful because for performance reasons, because you only pass the ID of the query and you don't pass the old GraphQL document. And also, it's something that can help with security issues because you can say, oh, I only allow the queries that I've selected, the ones that I need. This only works if you don't have a public API because you know which are the queries, but if you have a public API, it's not something that you want to use. Another approach is to limit the, for the security, for this long query stuff, it's to limit is to have a timeout on the query. So for example, if the query takes more than 1 second, you can just throw it up and throw an error to the user. Because if the query it's more than 1 second, it's something that you don't really want to use anyway, because it's slow and stuff. So before, I have this slide, why should you use GraphQL? I think GraphQL is a new technology, especially in Python, and it's not really mature, the library that we are using, especially in the documentation. The documentation is really poor, and I really hope to find some time to work on it. And also the code is not really easy to change. But yeah, other than that, GraphQL is really good because allows you to do powerful APIs without writing too much code. You can use it. You can use the same API on website, your mobile application, and you can also use by, like, you can do a public API. So that's, I think that's a good reason to use GraphQL. And also for the front end, I only touch on the backend right now, but for the front end, there is much, much more on this. There are two libraries right now which are the more popular. One is Apollo, which is like the community version of GraphQL client, I would say. And then there is Relay, which is the Facebook version. And they all have amazing features like offline support, batching of the queries, and all this stuff, caching, etc. So it's really good, especially, I think if you do a GraphQL API, the front-end person is going to love you because it's really easy to use. And I'm going to show you an example because what I showed you right now, it's stupid and not really helpful. So this is the API that I built yesterday. And this is using a Flask right now because I didn't have time to install Django and do everything, but it's really simple. So as I said, you create the schema passing the query and the mutation that you have. So let me show you the query. In this example, you have the user, which is a list of person, and then you have also special user, which is, again, a list of person. Then you have the resolve functions, which is, in this case, for the user, it's only it's returning only to user, and then you have special user, which is going to return 1. And I can show you how this works. So I'm going to get the users. So this is the query that we just done to get the user, but I can also get the special users. Which is from. It's not showing for some reason. Maybe there's something. Oh, right. This is what happens when you do stuff the day before. Thanks. I guess I need to refresh this. And also you can see something that's doing the camel casing for you, so you don't have to do, so you use the front-end convention, which is usually camel case because you use JavaScript. And as I said, you can also do something that I haven't said. You can batch queries. So for example, you can get multiple queries. For example, you can get the user's first name, and you can also get the special user at once. So instead of doing like 2 queries or more than 1, you can just do 1, and you get all the data that you have. And yeah, I wanted to show you the issue that can be with like security and nesting. So before that, let me show you the person. In this case, you have first name, last name, full name, fake name, bio, and a list of friends. So the full name is going to return just first and last name. Fake name is going to do a request to an API that I found yesterday. And bio is going to do bio, whatever. It's going to do another request, and it's going to throw an error. And then friends is going to return just a list of friends based on the length of the full name and the last name combined. So as you can see, it's returning like as I asked for, first name and the list of friends. But since the friends is another person, I can return the friends in there. I can go on and on. Here one. So this is going to be, especially if you're doing many database queries or you're dealing with external web services, this is going to be painful because it's going to be a long query. And so as I said, you can resolve like calculating the cost of the query. You can resolve by limiting with a timeout, or you can also resolve by counting the nesting. So for example, is 1, 2, 3, 4, 5, 6 levels of nesting. So you can say, oh, if it's more than 3 levels of nesting, that's not a valid query. And also, GraphQL is not limited to your database. You can use anything else. So for example, as I said, there is a fake name method in there. This is going to be a bit slow because it's going to do an API call for each user. And the example for it's returning the information. And something that you want to use with this is caching. So, for example, if you do a query for a single user, you are using an external API, for example, it's better if you cache it. Otherwise, it's going to be slow every time like this. And yeah, there is the same for bio. So you can get the biography for each user. Right now, it's returning fake HTML. But as you can see, there is a size argument, which defaults to short. And you can use this argument to change the length of the bio. For example, you can pass size, which is long. And you can get the long biography. And another thing I wanted to show is the errors. So instead of using HTTP for HTTP like status codes for the errors, you don't use that. Usually every GraphQL API returns 200 anytime, even if there is an error. The error is something that's built in the specification. You have a list of errors. And this is quite cool because, for example, I'm going to do this query and it works. But for example, if I do something that's wrong here, you get the errors. You get a list of errors. The size invalid must be one of short, long. But you can still get the data back. So if there is something that's going wrong, you can still show the data to your users and without breaking the experience. So, and then there is the mutation, as I showed you before. The mutation is quite similar to the query. So you have a list of arguments, in this case just A and B, and then you have the fields. So basically the mutation works like a query, but they also get an input, and you can specify the input. And then you have the mutate functions. In this case, get A and B, and then you can calculate the sum, and you send the sum back to the user, which is like this. Mutation sum A. Okay, sum. You can call, and it works like this. And as I said, you have types. So if, for example, I'm trying to send a string, this is not going to work. So the ID is going to show, oh, there is an error because it needs to be type and this is a string. And you also get an error from the GraphQL endpoint. Something that there is sometimes I can talk about. As you can see, I did a request here. And as I said before, you need to cache this stuff. There is a common pattern which is called data loader, which is basically a promise library, which instead of doing this, you do, for example, you do fake name loader.load, and you pass the ID, and this is going to return a promise, which is then fetched by the Graphene library. And if you use sync.io and a similar library, you can have them running concurrently instead of doing like one query after the other, which is quite slow, as you can imagine. And also, data loader can have cache in it already. Yeah. So yeah, that's it for me. If you have any question, there are some links here. You can find my website, but especially the documentation stuff, which is quite interesting. Thank you.